Alright, I'm on a bit of a roll, so might as well keep going. Day 7. No space left on device. Let's clear this out first. Okay. You can hear the birds chirping and raindrops hitting leaves as the expedition proceeds. Occasionally, you can even hear much louder sounds in the distance. How big do the animals get out here, anyway? The device the elves gave you has problems with more than just its communication system. You try to run a system update. Perhaps you can delete... And there's an error, no space left on drive. Perhaps you can delete some files to make space for the update. You browse around the file system to assess the situation and save the resulting terminal output, your puzzle input. The file system consists of a tree of files, plain data, and directories, which can contain other directories or files. The outermost directory is called /. You can navigate around the file system, moving into or out of the directories and listing the contents of the directory you're currently in. With the terminal output, lines that begin with $sign are commands you executed, very much like some modern computers. CD means change directory. This changes the directory in which directory is the current directory. But the specific result depends on the argument. CDX moves in one level. It looks in the current directory for the directory named X and makes it the current directory. CD ... moves out one level. It finds the directory that contains the current directory, then makes that directory the current directory. CD / switches the current directory to the outermost directory, /. ls means list. It prints out all the files and directories immediately contained by the current directory. 123 ABC means that the current directory contains a file named ABC with a size of 123. dir XYZ means that the current directory contains a directory named XYZ. Given the commands and output in the example above, you can determine that the file system visually looks like this. Here there are 4 directories, / the outermost directory, A and D, which are in /, and E, which is in A. These directories also contain files of various sizes. Since the disk is full, your first step should probably be to find the directories that are good candidates for deletion. To do this, you need to determine the total size of each directory. The total size of a directory is the sum of the size of the files it contains, directly or indirectly. Directories themselves do not count as having any intrinsic size. The total size of the directories above can be found as follows. To begin, find all the directories with a total size of at most 100,000. Then calculate the sum of their total sizes. In the example above, these directories are A and E. The sum of their total sizes is 95,437. In this example, this process can count files more than once. Okay. Not sure what this parenthetical note is about. As in this example, this process can count files more than once. Oh, I see. Directories A and E are the only ones which have a size less than 100,000, and A also contains E. Okay, got it. Find all the directories of the total size of the mouse 100,000. What is the sum of the total sizes of these directories? This one looks kind of tough. How should we store our file system? Probably some sort of array. Main function build fs takes in our input. Lines equals input dot split new. If we're starting on $, and we want to, let's see, if line 0, 1, 2, Fortunately, we just have 2 commands. So let's see if we are properly reading those. CC D7 part 1. Render input as any type. And we need to create our actual puzzle input. Let's get that real quick. Now can we compile? Yes. And we're getting no detection of CD or LS in our test input, which is incorrect. So what can we do about that? Starting to get sweaty. This problem's so hard. detecting our commands. We split a line on the spaces, and we take the third element of the resultant array. That should give us the directory name. Just make sure that works. So first we're going to root directory, and it looks like we're going to directory A. Yep. Then we go to E. Then we go ... directory D. Cool. Alright, that's working properly. Then, what do we want to do? Might be best to just simulate a tree structure. How could we do that? forgetting how to initialize objects of a custom type. Maybe I don't want type at all. I can just do a class. Okay. Looks good. Current node will be equal to the file system at first. If we ever go to /directory, then we set our current node back to the file system node. Otherwise, current node equals current node children, and then dir. Okay. You might also want to track size in here. Just make sure our node gets initialized properly. Fs is used before assigning. Is being initialized properly. And then, whenever we encounter ls, we will be in list mode. List mode false. list mode equals true. And when we're in list mode, then every new line we encounter is a file or directory contained within the current directory. Actually, I don't think that we need to track list mode, because that'll just be any line that doesn't start with $. Then we'll detect whether we're looking at a directory or a file. So if line 0 equals D, then it's just kind of a cheat way to detect looking at a directory. Vector equal line.split. This time it will be the first element. So we have the 0 element is dir itself, first element is the directory name. And then else we have let file size and file name equal line.split on space. Great. And here, let's try it. 23 minutes elapsed. I'm just changing the children data type to be a map so that I can access it like I was doing here. Okay, but back to the ls section. If we find a directory, then we want current node children dir to equal new node and we'll set the parent of the child node to be a current node. Okay, then we me do something similar over here. Current node.children of file name equals new node. File name dot parent equals new node. And then we set a size equal to file size. Strings not assignable to numbers, so we'll parse as that. Let's just see what happens. Crashing after we encounter the 3 LSs. So, it's probably when we do cd dot dot. If the directory equals dot dot, then we're going to change our current node equals current node dot parent. And if we have a parent, then we go there. Actually, if we don't have a parent, then we assume that we're at the file system, so we'll just stay at the file system. Can't find name dir. I think I've gotten my... I did one too many closing braces. Cool. Okay, we have a node, children A, B text, C data, and D node. Then these are registering with the proper sizes. It looks like node A and D have children as expected, but it would take a bit more doing. Let's do fs A and D. Okay, so then child A has directory E as a child, and it also has 2 files, 3 files. Yeah, 3 files as children. Is directory E being properly picked up? E should just have one file, so it does. Okay, this is looking alright. I'm sure that there are bugs related to duplicate directories and files being added to the children's map, but maybe we cross that bridge when we get there. So we have our file system built. Now we want to breadth first search through everything and sum up everything we find that is smaller than 100,000. We might have to double breadth first. First to calculate the size of directories, and then we do another search since our directories will be populated. Day 7. A bit of a doozy here. I'm just going to check if we're properly detecting the children of the root node. Calc size fs. Node size type any. Should be an array of node. Push child. TypeScript get each key value. Yeah. Okay. current node has a size, then that means we don't have to perform calculations on it. And we can just size plus equals current node dot size. Otherwise, it's a directory of unknown size, so we need to calculate the size of current node, and then we can add that size to our current node. And when we finally have calculated our size, we want to assign node.size equals size. Oh, it's time to fix the posture. Things are getting serious. Nodes pop. One bug I see is that we're going to be reassigning 0 to nodes that already have a size. I think that in the case that if nodes dot length equals 0, then we just return, because we already have a size. We're getting the right size for the outermost directory. We are getting the right size for directory A. Let's see, what about children A? And for directory E, we have the right size of 584. So now, we sum the size of every directory less than 100,000. Here's some I think it ended up being breadth first. One of the two. Equivalent outcomes. No children. We take that out.
Now we need to figure out where we put this flower and the bench and the flower. We need to really check inside flower.
If current node dot children object dot keys dot length is greater than 0. If this current node has children, that means it's a directory. So we're going to add its size to our running total of size. Plus equals, we also want to check that current node dot size is less than 100,000. Then size plus equals current node dot size. Cool. Let's see what happens here. Some sizes of file system. 95,437. Hey, nice. Now, if we try it with the real input, what are we getting? Bigger number. Hopefully this doesn't overflow number. Too high. This could be a challenge. I'm going to pause the recording and take a little bathroom break. Give me a minute. Okay, I'm back. And no real idea where I went wrong. Also, do I really need to be tracking the ls command? No. So there's supposed to be a % sign at the end. Another bug that might happen. No. Okay, here it looks like we're deleting a directory if we ever visit it twice. That's not totally true. Although, yeah, that could be a problem. But by fixing this, I think it would only make the result bigger. Yeah, it didn't change anything. So, what else? What else could be the issue? On further consideration, this calc size is recursive in nature, so I think it's more depth first search. Not that that matters. This needs to be 100,000, not a million. So now, come on, fingers crossed. Pogging. Part 2. Now you're ready to choose a directory to delete. The total disk space available to the file system is 7 D million. To run the update, you need unused space of at least 30 million. You need to find a directory you can delete that will free up enough space to run the update. In the example above, the total size of the outermost directory, and thus the total amount of used space, is 48,381,165. This means that the size of the unused space must currently be that number, which isn't quite the 30 million required by the update. Therefore, the update still requires a directory with a total size of at least 8,381,165 to be deleted before it can run. To achieve this, you have the following options. Delete directory E, which would increase unused space by 584, delete these other things, yada yada. Directories E and A are both too small. Deleting them would not free up enough space. However, directories D and / are both big enough. Between these, choose the smallest, D, increasing unused space by 24,933,642. Find the smallest directory that, if deleted, would free up enough space in the file system to run the update. What is the total size of that directory? Good question. I am going to copy what we have here. Day 7, part 2, TS. And modify. Destiny true. $70 1 2 3 4 5 6 70 million minus FS size. I'm still compiling day 1, or part 1. So this is right. Unused space, 21 million, which isn't quite 30 million. Need to free 83 million. Okay, we're getting that calculation correct. Pardon me, 8 million. Now, we need to do another similar search of the tree. Find smallest size. So the smallest size will start as the entire file system size, and then we search through the file system looking for directories that are bigger than need to free, but smaller than smallest size. And we return the smallest size. And we don't necessarily need to keep this constraint of only looking at directories. We could just delete a file, I think. No. Okay, it does have to be a directory that we delete. So we keep that. Current node.size is greater than need to free, and current node.size is smaller than smallest size, and smallest size equals current node.size. Need to free and smallest size of file system, and need to free is a number. Nice. It appears that this worked. try it on the real input. Sweet. Day 7 done. That's a lot of progress today. I think I did, like 4 days worth? Maybe I can knock out day 8 tonight, and then we'll be caught up. Sweet. Thanks for watching.